I guess you're the Zoom host. Rami, you're the research meeting host. So over to you.
Yeah, I guess, well, it's just a little bit of introduction. I guess Jeff wanted to start a discussion on the classes of objects. And this is I guess, a problem that Jeff was talking. This is something that we've been talking about for a few, I don't
Like
know, ever since I started, I guess, working here. So,
a long time.
yeah, a very long time. Um, which is just basically how what's the distinction between object and when we say an object ID, what does that really mean? What is included? Is it like a class of objects? Like, is it like a cup with a handle and a cup without a handle? Is that the same object ID, or is it like a different object ID? Maybe problems related to this, but also how it relates to learning in the hippocampus. And so, yeah, I think Jeff will guide us through a discussion on that. And after this, we as a team will talk about various topics for the focus week. That's in February. Um, and yeah, after that, I think Niels also has a few presentation slides or like drawings on policies, top-down policies that he's planning on working on next, I think, with Scott. So yeah, a lot of stuff to discuss today. So
A lot of stuff.
Yeah,
Did
we'll
I see
see.
some
We'll
other?
get into it.
Yeah, did I see some other notes on classes in that CalDraw panel you
Yeah,
had?
so I put some there, and that was just some of my thoughts based on because I was away last week, but I watched the presentation or last week's meeting, and I also saw your notes on Slack. So I just had some kind of thoughts on that. So that's what those are.
Great.
And
All right.
I can either do that now or I can wait until after.
Well,
Um, if,
I didn't look at yours. I just typed up some notes this morning in the same as
okay, yeah.
CalDraw thing. So I didn't, but I did look at yours first. So I'm like, maybe we're overlapping, maybe we're totally different. Who knows?
But I don't
Um,
think so. But yeah, I mean, who knows? Um,
yeah. Well, how do you want to go forward? You want me to just, I could lay
I
out
don't mind. I mean,
how,
mine's pretty brief, I think.
you want to go
So
first?
yeah, it could just be, and it's really about terminology almost. So maybe it's like a
Yeah.
helpful
Yeah.
grounding.
Okay. Okay.
Um, but yeah, so if I share my screen, so you guys are seeing this. So yeah, we talked about, as Rami said, for a long time, this kind of classes of objects and how to classify things. And yeah, you were talking, Jeff, about the importance of affordances for classification. Um,
That was just that day's idea.
right. Yeah,
Just be
and
careful.
so right, and so that's why this isn't kind of disagreeing with you. I guess I just thought it was helpful to kind of um at least from my mind, kind of like take a step back in terms of like where affordances and morphology fall in. And I think the way I think about it is that yeah, the affordances aren't necessarily special or like basically affordances are really useful because they're much more useful for behavior because by their very nature they kind of tell us how we can change the world and interact with the world. Um, and so they're very important for intelligence. Morphology can is a way to kind of easily or it is more accessible. You can kind of look at something and you can kind of instantly see what its morphology is, and generally that correlates with affordances. So a lot of objects look like what they look like tells you what you can do with about what you can do with them. Um, but I think both can be ways of classifying objects, and both at specific and generic levels. But yeah, in terms of, I guess that both are relevant. I have these kind of examples where, like, you may have seen that there's this trend on social media for people to bake cakes that look like something else. And so they'll have, like it'll be like an iron or it'll be, just like some everyday object, or here it's like an orange, but it's actually a cake. So, in this case, the morphology is very much of an orange. Like that's exactly what it looks like.
I guess I'm not
Um,
spending enough time on social media these days
yeah.
or YouTube videos or something.
And clearly your loss,
Yeah.
but but the affordance of this is, cake. You can eat it, it'll taste like cake. You can throw it at a wall and it'll smash like cake. Um, but then you could equally have something that has the morphology of cake, but is composed of something else. It's made of ceramic, and in this case, this is actually a lid to put on top of a real cake. Um, or, in this case, looks like a cake, but it's actually made of plastic, and also a toy for children. Um, so I guess it feels to me like, we'd have different types of columns kind of lighting up for this in different instances. We have columns that classify based over morphology that would be saying, yeah, this is an orange, but ones on behavior that if they get the right information, we'll be able to infer, okay, no, actually, this is a cake. Um, Obviously, how affordance is recognized and extracted is really hard. That's a much harder problem, which is why we don't have it in Monty right now. But it's also clearly important. Um, and yeah, I guess those were the main points. But yeah, and then just that, and maybe this wasn't the main point you were making, Jeff, but I feel like there was some discussion about kind of affordance being more general and morphology being more specific. But I feel like again, this can both can be specific or general. So like you can have a very specific instance of a cake or a mug or whatever, or you can have kind of the general shape of a cake, whatever representation it is that enables us to recognize that these two are the same morphology. Um, but then with affordances, you could also have like a very specific type of tool, like a very specific drill or a very specific screwdriver that interacts in a certain way. Or you could have the more general concept of a tool, or like a vessel. You could have, something like a pitcher, a water pitcher, pours in a very specific way, um, and kind of holds a certain amount and things like that. But you could also just have the concept of anything that can hold water, which might include something like a shoe or, you know, lots of objects. Um, but yeah, so basically those are just some thoughts on morphology and affordances, and maybe we kind of agree on all that.
Is this text what you just said?
Yeah, this is
Um,
basically what I was just saying.
yeah,
Um,
yeah. Well, I was taking a similar approach, which is um, without the nice pictures, of trying to get at the root of what this is. And trying and class. Is it what's the right terminology? What are the right representations? What the hell are we talking about? And if I can just start, I
yeah,
was thinking
please.
about learning in hippocampus, and I've used the example of an intersection before. And so I was just looking at it, and I realized that very often, if I get to a new intersection, it's a new intersection. It's different than other intersections I've seen, but I know it's an intersection. And when I'm learning a model of that new intersection, I have prior knowledge about what to expect, even not it's not specific prior knowledge, or maybe some variation. Some people specific, some could not. If I see a four-way intersection, I expect either to be a traffic light or stop signs or something. But I don't know which, but I have prior expectations about it. And so there's a lot of knowledge that comes into. So what I realized when I'm building these temporary models of the world, very often I start with some sort of class knowledge about what this thing is, and then I start filling in more of the details. And of course, so that we don't really have that kind of representation. We have a representation of very unique objects, like our coffee mug, and that has very detailed. The more I've learned it, very precise knowledge about it, and I can add things to it. I can add new features to that by observing, and building on top of that model. But that seems fundamentally different than starting with sort of a generic intersection or a generic mug and then adding features to that. But it really, the intersection example, for whatever worked for me, very precisely. It just said, I have knowledge about these new intersections. I know they're intersections, but I don't know anything. I know very little about them. So that brings the question of like, well, where is that knowledge stored? Um, how is it represented? How do I access it? How did I learn this knowledge? And so on. So I just wrote a few notes down in that same. Uh,
Okay, yeah.
uh,
Yeah, and,
yeah,
just to check my kind of understanding of kind of what you're bringing in here and stuff, because I guess we talked about like learning more generic models, that, wouldn't give as much detail. Right now, Monty only learns hyper detailed ones, but at least
right.
we've talked about how we might learn like a more coarse model.
Well, we've talked about maybe learning course models because we have course reference frames.
Yeah.
What else did we learn? Did we discuss besides that? Anything else?
Well,
Yeah, and I guess course reference frames, course inputs, um,
Right.
and then but then I think the thing that's hazier to me is this kind of expanding a model or branching a model when you want to start adding information,
Right.
which it sounds like you're also touching on, where it's like,
Right.
I have this course model, how can I leverage it
Well,
now,
I'm not
given
sure
a
the
more
course.
specific
I'm not
instance,
sure the
or
course model is the right way to think about it. I'm going to
okay,
throw out some suggestions.
yeah,
That was one idea, but it feels to me when if I have prior knowledge about a class of objects, very often it is not just a course or model of another one. It can be very, very different. And so I can come up with examples. So I sort of
yeah,
expanded ideas here.
like looking at the examples that Niels just showed, I feel like there may be two different versions of categories that we think about. One is the thing that might be possible to model with kind of coarse models, and especially also compositional models at higher levels. So for example, for a coffee mug, you might have a coarse model of a coffee mug, and a lot of different variations of coffee mugs roughly match that coarse model. But then, for example, with a car, if you just look at the morphology, even if you learn a coarse model, cars have a lot of variations, but still, if you the kind of child objects and their relative arrangement, like having four wheels in a specific
Right.
arrangement, a door and a window,
right.
that's still consistent, even across a lot of models of cars. So I
Right.
think if you have a coarse compositional model, that could capture all of the instances of cars, of specific cars,
Maybe
for
that's
example.
possible. But clearly,
But then,
the arrangement of children is a critical issue because I can arrange the children and not even show you the course model, and I'll still guess what it is. Right? I could show you the wheels and the windows and the doors, and I don't show you the picture of the car, and you'll say there's a car there. So,
But
but
you wouldn't perceive a car,
you
like,
know it's a car.
would
So
you? Or like,
well, if I
yeah, or
said,
like it feels like if someone showed, wait, so what's the presentation? You're seeing a wheel
I'm saying
disembodied from
I
a
can show
door.
you a suggestive set of features, and you'll know what the underlying class object is.
you mean, are they in the right like spatial arrangement,
Well,
or?
pretty much. But then you can go all the way to Picasso and say, oh, they're not in the right spatial arrangement. And I still know it's the person. Right? There's no.
But
I don't have any
it's not a
answers.
person, and I don't think we would say
But
it's a person.
so
Or
here's where
yeah.
I come down to it. Well, I'll get to this. One of the key things that I've always used for thinking about our models is that if I can put a label on it, if I could say the word for this thing, then there had to be someplace a model which took different inputs over time and pulled them into a single representation for that name. Right? That's just a fact. If I move my finger over an object, I get a series of inputs, and now I can say what that object is. There's a pooling operation and a model involved. And so if I can label the class, if I can say, oh, that's a car, even though I don't say, I'm not saying you perceive the car. I don't know what that means, but you know that the word is a car. And that tells you that there was a model underneath that. And the word car is not a specific model, it's a class model. And so there's a model there that somehow various inputs gets mapped into this single output. So that's going to be my sort of touchstone in the background here. So we could say whether I
Yeah.
perceive a car or not perceive a car. The brain perceives the right label for this is car, and you may say, yeah, I know that's missing things, that it doesn't look right, but you still know it. You can still label it. That's the crazy thing about it.
Yeah, so I guess what I was suggesting is that the thing that represents the car and is able to label it car is like a course compositional model that just stores four wheels relative to each other, window, door kind of thing. Instead,
Right.
and then you can learn more detailed models of specific car models in other columns, or
Right.
that store the kind of more detailed input.
That might be. I'm not dismissing that, but I want to keep options open that it could be more subtle than this. There are times where I see an object which I would, on first blush, say, "Oh, that I wouldn't say it's a car, right?" Or, or I say like, imagine I'm doing a CAPTCHA and says, "Oh, click all the boxes that are chairs," right? And there'd be an object that clearly is not a chair, it's a drum. And but if I said pick an object that could be used as a chair, so I don't know. I mean, I might pick the drum. What are the objects here that are chairs? And I might say, oh, well, that's a drum, but I also see it's a chair or something like that.
That feels quite different. At least if I like kind of paraphrase what what you were kind of saying, then yeah. So like as Vivian's talking about, and I agree, kind of we're talking about recognizing with like a reference frame, but with yeah, like child objects instead of just input features. And then I think what you were describing with the car is almost like pooling over a set of features, and that's sufficient to kind of recognize or like identify something. So like just the set of seeing a door handle, a wheel, and so forth, a tire, irrespective of their spatial arrangement, that's enough. But then there's the question of affordance. But I guess that's where you're getting to that somehow the set of features is predictive of or kind of correlates with affordances, and that's how we recognize it.
Right. I don't know. Right. So I found this very confusing. So I tried to back up and start from first principles. And so let me just show you the notes I wrote down. I'm not sure they're right. I just think it's my first attempt at sort of, whenever I get confused like this, I just feel like I need to back up somehow and just take a bigger picture or more fundamental picture of these things. Because clearly it's thinking about all these examples is very confusing, and we can't even agree what it is that I can't agree with myself. So it's like I can't agree what these things are. Okay, so just these are I wrote these 20 minutes ago. Okay, I have some notes in my notebook, so just take them for that. So the first one is the thing I started with. But often when learning something new, it starts with prior knowledge of a class. I use the example of the intersections. So this suggests that we have some sort of model of classes. I have a model of intersections. Somehow there's many different intersections that I've never seen, and yet when I see one, I say, oh, that's an intersection, and I can't make very specific predictions about it because I don't have this morphological model of this particular object. But it's the same thing if I see another strange-looking mug or a ceramic one I haven't seen before. That's a mug. So. But very often this is, I don't start off, with a blank slate and just start laying down points in a reference frame. It seems like very often we start with some sort of, oh, I know what this class of object is. How it's, I'll leave it at just that observation. We don't look at an intersection and say, I have no idea what this is. Let me just start laying down points. So there must be some internal representation of classes or that I recognize to say this is an intersection. The second question I asked, the next point was, are these models, and I'll call it class models and object models. So the object model is our current model, which is a very specific, features at locations and edges and so on. Are they separate things or on a continuum? Is it just like, oh, they're all the same basic model, but one's fuzzier than the other? Or are they separately represented in the brain someplace? If I had to guess today, I'd vote on the separate side. It's not what I want. I really wouldn't want that. But it seems to me that, this idea that, it's like a fuzzy version of a previously morphology model. It just doesn't seem quite right. But this is a question to ask. I think there's a fundamental question. Are we talking about class objects? Are they the same model using the same columns and the same, neural tissue, or are they represented separately, two separate models? I'm really talking about whether are they in the same physical column or something, or learning module, or are they separate?
And so when
Yeah, I
you
feel
say
like
you think they're separate, you would say they are just two models learned in the exact same way, but learned in two separate columns.
Right. Or they would,
Yeah.
but somehow they're different. Obviously, they're not exactly the same. They must be getting different inputs or something.
Yeah. So that would
Right.
match up kind of with the course model idea where the intersection class model is just learning there are two streets relative to each other in a specific arrangement, and it's like a higher level column that just gets street ID as input at location and orientation. It just learns those two streets
Yeah,
are
I'm not
90
sure.
degrees to each other.
I'm not sure if
And
it's consistent with that. I didn't follow all that, Vivian.
mm,
You know,
basically that you learn like a high level compositional model of an intersection while you're learning a specific. So you're learning a specific intersection. While you do that, you're learning a higher level compositional model of it that just stores street ID at that location, street ID at
maybe
that location. And
that's a good
then
guess.
when you see a new intersection, you can still recognize that high level compositional object and use top-down connections from that or some bias from that to make predictions about the new intersection.
Perhaps. Although in that case, that higher level learning module, it also learns very specific objects too. I mean, a larger one in the field of view.
I guess
mean,
if it
is it
gets sensory input as well, it could.
so
But
that would be in the then that would you're arguing that that it's a continuum. It's the same object model system we have right now, not a separate one.
Which
Like
is
Yeah,
what my
a
vote would be
separate
for that.
a
That
separate
yeah,
one.
some receive just sensory input, some receive lower level column and sensory input, and some receive just lower level column input. And yeah,
yeah,
The
like
thing I was go ahead.
I would argue there isn't a specific extra layer or something in each column
Right.
that represents a class ID, but instead each column just learns objects, and some of them learn more abstract representations of an object, which is kind of like a class, and more coarse representation.
But
And others
why
learn
would it? But
more
why would it
specific.
learn that? How can you say one's going to learn coarse
based on
ones and
its
one's not going
input
to? But
and
its input is.
also the reference frame, but can be
I
If I
think
have a scaled up reference frame and a scaled up input, then I could learn a very detailed model of a larger object. I'm sorry, Hoja, I think you want to say something.
yeah, and I think another possible mechanism is that we get the same, inputs, but I'm trying to think if there's like trying to look up the connections, if there's anything from like layer 1 or 2 that can get kind of combined so that in layer 3 the ID that we get can be sometimes a unique ID or the class ID. Like it's the feature set locations, but then some kind of context or kind of how we're looking at the object suddenly kind of gives us a different ID.
Well, or you're saying there's two IDs in a column? Is that what you're saying? Like there's an object ID and a class ID? Or
Yeah.
maybe
So like
yeah.
we
Well,
can have the same features and locations, but it's not just that determines the ID, but that and some kind of contextual information
right,
that
which is
influences the final ID.
Yeah, so to your point, Jeff, about like how do you then use that model now to learn like specific details or something? Something we talked about before is kind of conditioning on something like a state to kind of provide additional predictions about what we'd expect in the reference frame. So
right. That
maybe
was a
we have
similar
this
idea,
kind of
but
generic intersection one, but then it can have we can have 4 or 5 different states which correspond to maybe different intersections we're actually familiar with, and when we know okay it's that one, then it kind of conditions that to say okay there's a specific additional prediction at this location.
maybe. So I think it would be helpful to get some more of these ideas on the table, maybe. Um, when we talk about these things, like we're thinking about maybe like classes like a state. Look at my fifth bullet there. I say multiple unique objects per class and multiple classes per object. So this is just an observation that if I come up with something like a mug, I know many unique objects that I would classify as a mug, but also a unique object can have multiple classes. It can be a vessel, it can be a mug, it could be, a shoehorn. I don't know what, I've come up with examples where and this just complicates this idea. It's not like all
Yeah,
right. So that
I mean that feels like that would be more like different columns. Like I could imagine
right.
it's kind of like many to one versus 120. Like I can imagine many mugs being presented to a generic mug column and it's saying yeah that's a mug, but then
Right.
many different columns which model different things like vessel behaviors and stuff like that lighting up when they see a
Right.
mug.
So I don't really have a proposal here, but I don't want to keep going through some of these observations because I feel we have to resolve all of these somehow. Can I go to my third one here, which is, one of the things I noticed is you can't really learn a class object without I'm going to make the statement, see if I can support it. You can't learn a class object without either simultaneously or first learning a unique object. It's like I can't learn the class of mugs before I've learned a bunch of mugs. Like I would only know one. There would be no class to it. And so this begs the question: when I'm learning a new object, am I somehow laying the foundations for the class at the same time? So this would be along the lines of maybe the arrangement of features is I have a specific arrangement of features, but for this particular object, but that's going to be the foundation for a class. Or it could be that I have to learn a bunch of unique objects first before any sort of memory of a class comes out. I don't know, but the point is classes are learned, and I think we have to sort of understand the learning process. Like, okay, is it something I do at the same time as I'm learning a unique object, or is it something that it gets derived later somehow? That's just it's just an open statement, but I think it's worth just thinking about the fact that, oh yeah, I can't just talk about class objects in abstract. I have to be learning unique objects either at the same time or prior to them.
That one seems like it would be a bit hard to falsify, because the definition of a class is basically that there are multiple different instances of it. So like there isn't an example we could think through where that wouldn't be the
Right.
case.
But there's two possibilities to do that. So I agree. First of all, it's just worth stating so that we think about it. So I think it's obvious but it's just worth stating. To me, it was worth it to me to state that, saying, oh yes, I can't think about classes, learning a class, without talking about learning unique objects simultaneously or first. So then it did bring these two possibilities of that they're learned at the same time, and we just don't know we're learning a class until we need it, or that you don't actually learn the class until you've seen a bunch of observations of unique objects, and then you can say, aha, those things are all in the class, because I don't know how. I don't know that.
Yeah, I mean, I think, yeah, I agree. It's kind of a necessity to learn on a specific instance of a class to be able to learn the class. But I think you could only see one instance of the class and have a mechanism that still learns a more abstract representation of that, and that generalizes to a new instance of that class.
Right, that I can imagine that, but I can also, I think I could spend more time on it. I think I can imagine situations where I learned some unique objects where the common class isn't, well, maybe it's not knowable until some future observation. I don't know.
Yeah, because I feel like, for example, like a Segway. Let's say you've never seen a Segway before, but you've seen lots of other vehicles and things like that. So now you see this object that has these two wheels, this kind of little platform, and these handles. And now you see another example of a Segway built by a different company, different, branding, different details, but you recognize, oh, that's the same thing as what I saw before. And I think that makes use of these kinds of abstract representations of like, oh, it's this arrangement of wheels and so forth. And you didn't need to see multiple instances of a Segway to now generalize and say, okay, this is similar to this one instance of this thing I've seen before.
It feels
Yeah.
like possibility one would only work with morphology-based classes of objects. But I'd be able to build a generic model of the same thing, maybe like a sparser model that is more generic. I could do that at the same time. But what about classes of objects that are based on affordances, or things that you see in the same locations over time?
Right.
Like you can't do that from just one observation. You need to view them multiple times.
Yeah,
Well,
that's, I guess, the point I didn't get to earlier about there seem to be two ways we classify things. One is kind of morphological similarities, that like even if the overall morphologies can be quite different, like with dogs or cars, the relative arrangement of child features is consistent. But then the other way we categorize is what you just bring up, like affordances or other properties that objects have, like cakes being sweet and made out of dough. that's more like a property of the whole object. But I feel like that's almost the easier one to solve, because that might just be another model in another column of like sweet food, a column that models whatever you get from your taste buds, and whenever that one is active, you label that as a cake.
Right. But right now we only have one type of model. Well, we could talk about, including composition, but I'm talking about like, I guess our behavioral models would be another type. But when we think about an object right now, we don't have any idea of class. We just have, very unique morphology. And so we're talking about things like, oh, here's a model of sweet things. Well, we don't know how to do that, right? We don't have any of that right now. So
Yeah, and I feel
think
like, yeah.
we're getting at a fundamental capability of Monty that we haven't resolved at all. And it's in my mind, it's I want to go back and say, oh, are we adding class stuff to the existing models, or do we have separate models for classes, or both?
Well, I could believe that affordances are quite a different type of model. Again, kind of like a behavioral model, that it's again through differences in inputs and things like that. It's just effectively going to learn a different model. I think that makes sense. And like, but yeah, I'm surprised, Vivian. Yeah, you're saying that's the easier one, because I feel like, say with something like, oh, something's a chair or something's a vessel. Like, I think we generally have an intuition that probably relies on some sort of like mental simulation and being able to say like, okay, if I pour fluid into this, it's going to hold it, or if I sit on this, it's going to support my weight.
Yeah,
Well,
I wasn't talking about
But
the
I feel like that's really,
affordances.
if we had to build that right now in Monty, like that's really hard.
but it's
Yeah,
not
no, I
just.
was referring more to like basic properties of objects, like all the sweet objects or all the green and blue objects or whatever. Like you
Okay,
can
yeah,
categorize things by a lot of like all the round things. I don't know. Like
right.
Just going back to what you just said a second ago, Niels, yes, we do simulation, but I have to have something, there has to be something about the object that I observe that suggests I do the little simulation. I'm not going to look at, a tea
Right.
kettle and say, oh, well, can I drive that tea kettle down the street? No, I'm not going to do that. It's like, okay, is there
Yeah.
a switch? So,
Yeah, in that sense, that kind of feels like a sort of model-free signal. Like it's almost like recognizing, I mean, eventually you'd learn something and then you'd have just a good shortcut. But let's say you're kind of, this is a fairly novel thing, you'd have kind of model-free signals almost for, although maybe they're not truly model-free, but sort
how
of
can we?
bottom-up signals for what is the search space for my mental simulation.
So it's not model
And
free, right?
then
It's
I know,
wouldn't it
but
be
do
like?
you see what I mean by, as in before I start simulating something, so maybe simulation free, heuristics for like what are the simulations I'm going to try and play out,
Right.
and then like you say, you wouldn't try all of them.
I think the simulations, I would do that for even well-known unique morphology objects. To me, it has to start with some observation of the thing you're looking at. It could be a morphological observation, or it could be behavioral observation. Those are, right, as far as I know, the only two choices we have. And either the shape of things and relative position of things, or it's how the thing is moving, suggests some utility or class that I don't know. Let me just, the second, these 1, 2, and 3 down here, this is my beginning list of possible methods of how we might model classes. And maybe I'm missing something, and there could be more, and I just started this. So one is the idea of, I'll just call it the fuzzy object model based on larger scale. It's like we got the same basic system we have now, but because at times is, the scale of the reference frame, the scale of the features based on the different inherent scale of learning modules, that we have some fuzzy models and some non-fuzzy models, and that's the basis of it. So it doesn't introduce any new functionality to the learning modules. It's just we have to figure out how when they work in a hierarchy of scale, that somehow that leads to classes. The other one is, you go ahead.
I guess on that one, I would, if you don't have another alternative for that, I would add to that. It doesn't only need to be like fuzziness of how many points you can store, but also how abstract the points are. Like, do the points represent abstract features, or do they represent like low-level sensory input? And
But is that your
well,
point too here, Jeff?
I don't know. I
I
mean,
think
thought
in
this
my
was
mind,
valid.
in my models, our current morphological models have two components, right? There's the observed simple features like edges and point normals and stuff, and then there is the complex abstract things we can associate with those points. Remember that this
yeah,
is
and
where
so if we
right.
associate
So
more like more detailed models that were learned at lower levels, we need a lot less points to learn an abstract representation of an object. Like a car, you just associate wheel, 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 wheel.
right.
Like,
So I guess I'm not saying this point number one here is not inconsistent with that. How would you want to change that to?
no, I would just add based on larger scale and more abstract input features.
The thing about abstraction is that you still need to define the class of objects that governs this abstraction. Like, how would you say, like, if you're looking at a car and you're saying wheel, 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 then you need to have a class of objects that
Well, we
specify
have a
the
class of
wheel.
objects. We do have a class of objects that are wheels. Right, but I think that's consistent, right? It would work, wouldn't it, Rami? Basically you're passing.
Yeah,
Yeah,
The,
I
there
think
would
just
be
the point is
basically
eventually
another.
you'd bottom out to morphology models, but morphology or affordance models, but I don't think that's necessarily a problem.
I think the word abstract feature, you're just saying it's an input feature that's not an edge, right? It's a
Yeah, it's something that's the output of another column.
right. The word abstract is
But it also groups
and
Just
multiple
child object.
child object, yeah. Okay, type child object input features. Is that okay for now?
Yeah.
Okay. If this was the case, by the way, this would require that there be two. I'm going to propose it requires that there's two IDs for the column or two IDs for the learning module. There has to be a class ID and there'd have to be a unique object ID, because I need to get. There has to be a model ID someplace in the system. So
Why would
yeah.
it require that?
If I have to have a model ID, which I'm going to argue we do, and this is essentially this number one here is essentially introducing no new functionality to Monty. It's just saying, oh, this is going to come out naturally in the way that hierarchy works,
Yeah.
and the scale works. So the columns, the learning modules we haven't changing them. But if I need an object ID, if I did an object ID and a model ID, which I'll argue we do, then I have to have something that represents the class ID and the object ID. Then I need to have a class ID there.
They
What's the
would be in
difference
different
between-
columns, is what I would argue. You would have a column that learned a detailed model of that specific car, and then you'd have a column that learned a more abstract representation of
Are these
car.
columns, are they doing this
Right.
because they're at different levels in the hierarchy or because they
Yeah.
operate fundamental? Okay. So you're saying the object ID of the high level column is by default, it just turns out will look like a class.
Yeah.
Yeah.
Okay, so let me just be clear. Let me write that down. Learning modules. Yeah, sorry, I switched back and forth learning modules. I always think columns, but I know you guys think learning modules. So,
I'm sorry, we can stick with columns.
okay. I know you're smarter than I am. Columns. How about this? A columns. Object ID can be unique lower level column or class upper level column, something like that. Is that okay? Is that
Yeah. And the
I-
nice thing about why I'm kind of, so I also previously liked that idea where we were thinking about, oh, there's a class ID in the column, and then we have different states of that class. But that kind of doesn't work with this other observation you wrote down earlier, that like one object can be a member of many different classes. And this solution would solve that, in that we can have models of various classes at various levels of abstractions in different columns, and they can all be recognized at the same time on the same object, just because each column has learned models at different abstractions and with different input.
Right. So this idea, number one here, is intriguing to me personally, but it's not clear to me personally. It's like, it's sort of like, oh, it sounds kind of good, but I just, it's something about it that's still sort of, I don't know, I'm not sure. So, but I think it's definitely worth exploring further. Now this may be, I put this down, the number 2 here. Maybe this is number 2 is redundant now. I don't know. I said a relative arrangement of similar or identical features. Well, this would be like the features are coming from lower levels, and the relative arrangement is somehow captured in the fuzzy model above it. I'm not sure.
So when you say
I was.
not location accurate, does that refer to kind of a fuzzy model, or does it
It
mean
does. It
location
applies.
doesn't
It applies
matter?
to the locations of these things aren't precise, right?
Okay.
They could be moving around a lot,
Yeah.
not completely. It's a relative arrangement, but the again, when I pick up a particular, my coffee mug, I have a very precise prediction about where the features are. I know exactly where everything is. But a new object, I don't have that, but I have, it's like a, it's not precise at that point. So it's not
Yeah.
it's not accurate. I can't say, oh, I know exactly what I'm gonna feel at this location. It's like, oh, there's going to be a handle or somewhere over here. I don't know.
I mean, it feels like, yeah,
Yeah.
again, what's nice about having multiple columns is things like, a car, you could also recognize a Corvette, or you could recognize a pickup truck, and all these things. And a lot of it is just kind of a question of how granular you want to be, or, you can recognize a particular make of a car. Um, so I feel like
Or
trying to separate out object from class, like, yeah, I feel like it is just a continuum.
I don't know. I can imagine, like, I look at some object and I don't see morphological similarity to any other object I've got. But then I look at a subset of the features, just a subset of the features. And that subset of the features suggests, oh, maybe this is in the class of X. But the rest of it, maybe it's like a stapler that has all kinds of funny ornamentation. And but then I see the hinge and I see the deflection plate, and I go, oh, I guess it must be a stapler, even though it looks like a flower. So I don't know.
But yeah, I mean, doesn't that fit with having multiple columns? So you have a column that recognizes the flower-like nature of it at the same time. But rather, it just feels
Well,
like
I don't know. I mean,
it
that implies
it's
that
going to become
the classification is ignoring most of the object. It's ignoring most of the morphology. It's just saying, oh, there's a few things here in this arrangement, and the rest of the things don't make any sense for this, So that particular object could be, a flower, decorative flower piece, or it could be a stapler, or it's 2 different classes. It's hard to imagine a single column. Well, I don't know. I'm very confused by this, so I don't know.
yeah, I guess it just feels the more we try and shove this into one column, the more it's like, how many layers do we want? Like, we'll keep needing more and more layers. But if
Right.
we separate it, like, to capture, class level, unique ID level, maybe affordances level.
Well, that's the next thing
Yeah.
down here. My third one is a general class of possible ways of doing this, right? Possible, these are possible general directions. So number 1 is, okay, we use our common mechanism now, but relying on the different scales of the columns in a hierarchy. number 2 I thought was different, but maybe it's not. It basically it's saying, oh, some subset of the features are similar to somehow to a subset of features elsewhere. They're not even in the exact same order, but they're somehow relatively similar to elsewhere. So it's only a part of the object that is being recognized as a class. And then the third one was this idea that I threw out a while ago, which was like, hey, maybe it's a set of behavioral models. Like I look at an object and say, oh, I recognize a behavioral model potentially in this location, and that's going to define one class. This is like the stapler idea. And then, and even the mug, you could argue there might be some sort of, I don't know, you can talk about affordances. We haven't really defined what exactly that is in the tissue here. But I look at a mug and I say, oh, that's got a lip. So maybe that's where I put my mouth, and it's got a vessel, a container on the other side of it so I can drink from it, it's something like that. But a lot of things could have that combination. Anyway, my point was one was basic on shared functions. One's about a subset of the object. Those are, there's similar features in some subset of the object, and the third one is like, no, we don't have to do anything different. The first one, it's just like use our existing stuff.
Yeah, I think the point about only a subset of the object matching is a good point, but it doesn't necessarily need to be an issue with the solution of number 1. Like, for example, if you see an on button on a new electrical appliance that you've never seen before, you recognize the on switch, and on switch ID would become the input to, I don't know, electrical appliance class. And although it's not a lot of evidence for electrical appliance, it is one crucial feature that appears on electrical appliances. Then you might see the plug, which is another feature for electrical appliance class. And so that way, like even if only a few of the sub features fit, you might still have reasonable evidence for that class.
Right, but that doesn't seem like it would be. It seemed like that would be hard to fit into number 1, where the overall morphology of this object is completely different. But since it has a plug and a switch, I put it into some classification, even though everything else is different. There's nothing fuzzy about it. There's no and even the child objects are not in any particular arrangement. It's like, oh, I have a plug, and even it may not even look like a plug. Maybe it's a wall adapter. So then I look for little prongs, or I see a plug. I don't know. This thing is baffling to think about.
I feel like there needs to be like a possibility 3. Sorry, I'm kind of going up the bullet points. Possibility 3, 1, 2, where I feel
I'm
like
sorry.
class IDs.
We have 1, 2, and 3 labeled here. Or are you suggesting?
No. I'm saying under observation, we can't learn a class object without learning a unique object.
Oh, okay,
And
yeah.
then the third possibility being, I feel like class IDs are becoming more kind of abstract, or something like concepts that may possibly exist, and then we later associate unique objects with them.
Well, that okay. So you're saying the opposite. You're saying we can learn a class before we learn a unique object. Is that what you're saying?
Not exactly, but it's just that sometimes I think class, or like, I don't like the word class IDs anymore. Like categories or abstract concept, like I associate with it. So for example, I recently learned that coriander and cilantro are from the same plant.
Right.
Or are the same plant.
They are the same plant, right?
It's
They
just
are the
a
same
different
plant.
word. Yeah.
This always trips
Yeah.
me up. I know this, but every time I go, I get confused every time.
Yeah. Like, I mean, it was kind of mind blowing to me. I was like, oh my God, like, yeah. So like this concept of like this plant existed, and I started associating now. I mean, now I can associate that with coriander and also the cilantro. Or let's say with another example is with let's say we have a particular apple, green apple, Granny Smith apple, that can fall under, a general class of apples or fruits. or sweet
You know,
things or
by the way,
cookables.
interesting.
Like, but
A Granny Smith apple is not is unique as our Dementic or the Thousand Branch coffee mug, right? Because the Granny
yeah,
Smith apples come in all different sizes,
right.
um, and
So I feel like,
shapes.
yeah, I feel like this concept of fruit, like it's a like just an idea that somehow like I'm thinking of it as like somehow these exist and then we associate unique objects with them.
Well,
Or isn't it more
it's
you
going.
associate language with them? Is that what you're kind of getting at?
Maybe, maybe
Like
it's
you
language.
can
I
have
don't
a
know.
concept before you know the word for it.
Yeah, possibly, yeah. But ultimately, I'm thinking that not as like something that's derived, but something that we form association like with. Anyway, just a thought.
So in terms of
Well,
possibility 3, should that be we learn object class first and then and then associate specific instances?
Let's say we learn object class separately, and then associate
well, okay. Well,
with specific
that's
instances.
well,
Yeah,
that would be first. If I'm going to associate with it, I have to have it learn
sure.
something. Well, one possibility to make this work. What you're saying is might be. You might say, well, class. I'll just throw out an idea. Class objects don't exist without language. Let me just throw that. I don't know if I believe that. I'm just saying that. And so
Right,
someone says, this is a fruit, this is a fruit, this is a fruit, this is a fruit. And so the association of all these different other objects to fruit is not in a model of fruit. It's just this class idea that has been imposed, and all these different things that we know about could be associated with that class ID. Like the class ID comes from language, not from the objects themselves. That would be
right.
consistent, I think, with what you're saying.
Maybe with abstract concepts, maybe that's language. I don't know, but I feel like
It's
suddenly this feels a lot closer to learning abstract things than
okay.
before.
Well, let me
Yeah.
just. This may not be what you're saying, but I'm gonna state this separately. It is.
Okay.
Is it possible that class IDs or classes are not inherent, but have to be learned through language or through example or something like that? I mean, like if I never had any language in my life, um, would I learn the different? Would I have the same concepts of classes? Would I see a bunch of objects and say, oh, those are all mugs, even though I don't have the word mug? There's no word. I somehow see they're all. I think I
Yeah.
I
would see
mean,
them as similar.
yeah, why wouldn't you? It seems like that's a general capability that also animals have, to be like, okay, I'm gonna hide all my food over here, even though the food has various shapes and sizes, or
Right, right.
uh, but
Well,
these are my enemies, or things
I
like
believe
that.
with you. I believe you. But the one counterexample might be there are things we consider fruits that people don't realize are fruits until you tell them. So
Right.
technically, a tomato is a fruit, but most people don't think of it as a fruit. Most people don't know it's a fruit. They think it's a vegetable. Right? Technically, it's a fruit. So if you want to be precise,
Yeah,
so
but
Yeah.
that's based on, yeah, I think it kind of comes down to affordances. Like we have certain ways based on context and how objects are used of kind of learning coarse classifications. Fruit, what people tend to think of fruit are sweet things.
juicy, maybe.
Yeah, juicy
Yeah.
kind of plant products. And then vegetables tend to be savory. I mean, vegetables don't have, they're a culinary term. They don't have a scientific definition. Um,
Right. I'm just saying,
and
but it is a class we can learn. Um,
Yeah.
and
For
so it
animals, it
does.
could be just like
It
instead of food, it could be like edibles, like things that I can eat. Like maybe they don't have the word for it, but they know kind of by affordance, it's something I can eat, so I'm gonna hide it.
can I do this? So, I'm gonna try this. Sometimes um, a class can be assigned to an object via, I'll just say via language, where um, there are no other connections. I'm not sure if this is true, but this is, it could be a made up term, and I can just say, yes, these 5 things are in the same class. And, I'm thinking of tomato. But, is this possible that sometimes there's a class that exists, and you can just assign random things to it and say, yes, that's also part of this class. I'm not
Yeah,
sure I
I think
believe this.
yeah.
Right.
Well,
Like I can go
Um,
around and start saying this is a goop, and then people will be like, "Oh,
right,
interesting. Like, what's a goop?"
right,
But if I show this
right.
again, people will be like, "Oh, that was the goop
Yeah, I guess
you
the
brought to the
tomato
outputs."
one, tomato one is sort of the counterexample to this. The tomato one says, "Oh, I can see the similarities to fruits, right? They're round. They have the skin. They have juice inside. Oh, it's not like most fruits, but there are enough similarities there. Whereas, if I just said, oh, the tomato's a goop and a flower pot's a goop, you might go, what the hell? I can't figure this out.
maybe they think that you're
Um,
a baby who just knows
uh,
goop.
all right,
So,
so
There, there's a clear example, which is numerosity with lots of evidential experience without language, where both humans, pre-language humans and animals understand the concept of one, two, or three and can do basic arithmetic. And that does not require language at all. But
right.
oneness,
Is that a
two-ness
is that
is
a
a class
is that
concept.
is it a class? That's interesting. It's interesting that I think the question there is oneness, two-ness, and three-ness a class, or is it something else?
that's why I say that I feel like class, it feels more like an abstract concept now. Kind of, yeah. Or like a category.
But clearly, this most of the examples we can come up with, the classness has some relationship to the physical and behavioral aspects of an observed object.
Right, right. But
Well, isn't it just a way of referring to a representation, to a model? Like it is the kind of the output of a column. So a class might be something like democracy or something, but it's just it's it's basically a concept. And I guess often in machine learning and stuff, people are concerned with categorizing objects, so we use the term class, but it doesn't need to be that narrow.
Right, but if possibility, excuse me, if method number one is correct, down below, uh, I would argue the things you just said, Niels, would suggest that the class ID is not the same as the object ID.
How come? Because so for a very
Because
abstract
because
concept, that would be learned based on children in some reference frame.
hmm. But there's always a specific version. Like imagine I had some chart, a little picture that illustrated democracy. Um, and as a child, I look at this picture and it has little, image. I remember that very specific thing. That's, it's the first thing I've learned about democracy, and it shows these. And so I have this very specific memory of that. But then the concept of democracy is independent of that thing. Um,
But those could just emerge in parallel,
It would just be in two different columns.
right?
uh, you're
One
saying
learned.
again,
Or
whenever we say
potentially
two different
even one in Hippocampus, like
whenever we say two different columns, we're always referring to basically columns, different levels in the hierarchy. Is that correct? Is that what you mean?
Yeah,
Because there's
yeah,
no,
or
or
there's
you
no.
different parts of cortex. I mean, you could have
Well,
different low-level columns as well, or different high-level columns.
the distinction between I mean, I have very specific models of things, and I have class models. So if I'm going to use the same mechanism for both, I have to have some reason why some would form someplace and some would form the other. So the only thing proposed so far is, if I understand it, is the difference between a unique model and the class model is the ones at the bottom of the hierarchy are generally always going to be more unique. They're going to be
I,
like,
I
is
guess what I'm
that
saying
right?
is, and I think Vivian's saying this as well, is that it's on a continuum in that, like, depending on what the children are, for example, you could have more or less detailed models as well. Like, it's not like either you have children that are from other columns and it's an abstract representation, or you have direct sensory input. Um, you can have kind of direct sensory input models that are more detailed or more fuzzy, and you can have more abstract models that are based on children that are more detailed or more fuzzy, and that depend on the nature of those children and the reference frame they're being learned in.
I don't know. I'm still struggling with this idea because it seems that my unique models, like the models we've built today, um, they're very precise. They're just, there's no variation there. Even if the reference frames are fuzzy or something, they're still precise. They are specific objects,
But so
it's
what would keep you from just learning them like why would you need to learn them in the same column as where you learn the category of the object?
I didn't say that. They could be elsewhere. They could be like,
But if you're saying there needs to be a separate class ID from the object ID, the way I interpreted that was that the column has two different IDs, the object and the class ID. But maybe that's not what you meant.
well, that's one way, or you could have different columns. Like you could have we talked about
Okay,
like
yeah, so that's, yeah, I think
like
that's
with those are more like the what and where pathway type of thing. That goes back to the functional. There's a functional
yeah,
model. Functional model that's a class ID, and there's a morphology model, which is with the object ID. We've already accepted there's that one distinction between those two separate parts of the cortex. I'm
yeah,
not suggesting more.
yeah, then I think I would, so just kind of thinking of like, yeah, the lower you are in the hierarchy, you learn more specific models, and the higher you are, you learn more abstract models that are more encompassing classes. And then maybe
Okay.
the one exception would be in the hippocampus, you could learn very specific instance models as well. And actually you might learn a temporary specific instance model in the hippocampus. Like I show you a
You
new
can, right.
animal, and then
You
but you
do.
learn an abstract model, and the next time you see another member of that species, you may not even remember how exactly the animal looked like when you first learned about it.
Mm.
But you still
So,
recognize the member of that species later on and have that more
just
abstract
as an
model.
aside here, I came to an interesting observation thinking about the hippocampus, because what we know about it, it has a series of grid cell modules, which we are now assuming they represent column equivalents, right? And there's not that many of them. I get different numbers when I look through research, but 15 or something, I don't know. And they all vary by scale, right? So there's like one column equivalent at one small scale, the next scale, the next scale, the next scale. That seems to be that's a working assumption at the moment. I'm not sure it's true, but it's a working assumption. And so it models the cortex in its inception, where the cortex you have a whole region at one scale, then another region, another scale, another region, another scale. And so I was working through this, how the hippocampus might learn in such a situation. And I came to some interesting observations, which I think I don't want to try to explain it right now, but there's a parallel construction going on up there. And so it implied that what I ended up concluding that the columns in the hippocampus, in the entorhinal cortex in the hippocampus, that have the small scale should have fairly direct connections to regions in the cortex that are small scale, and the medium ones should have connections to the medium ones in the cortex, and the large ones should have connections. So it's not like information flows from region to region to region up the cortex, and then it flows from column to column to column in the hippocampus. It's more like associated with each region in the cortex, there is an equivalent column in the hippocampus. And I did find some evidence for that. They said, oh, yes, and B2 projects to, directly to the entorhinal cortex. But I couldn't find other ones, but I don't think people are looking for it. Anyway, I bring this up because I think part of the solution here, we have to include the hippocampus. We have to understand how the whole system works. And I'm in a future meeting, I'll propose some ideas perhaps about how we can fold that in here. And it just, the conversation we're having today reminds me that we have to include that. Like we can't ignore that. It's like we can't solve this in one spot. So a column in the hippocampus may be interacting with a region in the cortex in a way that that's not obvious right now. All right. Can I maybe, we've been at this for a while. I would like to suggest we take a break on this topic. I think today's conversation left us with the most favored proposal right now is the number one proposal here, possible methods of class models. Maybe the word fuzzy object isn't the right thing, but it's essentially that a single column, still works the way we think it works. But as you go up the hierarchy, you switch to more abstract features where the morphology is less important, but the features are more important. And that naturally some of the IDs of the column would at the higher level would be more model, class IDs, and at the lower levels they'd be more object IDs or specific object IDs. But there was a continuum between them, and in that this is the basic framework. We're trying to figure it out. And so if I stated that correctly, and no one wants to object to that, then for the next week or so I could work on that particular idea and forget about all the other ones.
And I would agree in that, and I would just say that I feel like 3 it's not mutually incompatible with 3, in the same way that we can learn behaviors as well as morphology models. We can learn, like we learn models that kind of help us categorize things based on their morphology, and we learn models that help us categorize them based on what they do and how we can interact with them.
Right. In fact, it's a good point, because even the extreme version of that, the simplest and extreme version of that, is that a child to an object can be either another morphological object or it can be a behavioral object, and the parent object doesn't really know the difference between the two. It just says, oh, there's some object observed at this location, and so then number one, the fuzzy object thing says, oh yeah, the components that are similar could be morphological components, or they could be behavioral components.
Right. Yeah. And so like a kid could build like a toy car where he's using like a spinning wheel. I don't know. Sorry, a spinning brick that is a very poor tire, a poor wheel. But because it has the affordance of turning, the child understands that this can now kind of drive forward. It has, I don't know, it's kind of in that category.
Right.
And then
Okay, so
I don't know if it's helpful. I don't know if 2 we should just delete, because at least as far as I read it, this is just kind of a rephrasing of the second half of 1.
Right. I agree with that.
And then maybe we just add a note for posterity, the mutual compatibility, assuming we agree on that, the shared functions affordance.
All right. So I'll just say we're going to get rid of number 3. Shared functions. I'm just going to put some cryptic notes here. Behavioral objects.
I think the interesting part in 2 that's maybe not included in 3 yet.
I just erased it.
Or maybe I'll wait until you're done.
Are treated, are both children, and treated similarly. Is that okay?
Yeah. Yeah, and then I guess, I agree that 2 and 1 also seem quite similar, not incompatible. Just the one part about 2 that we might want to come back to is the part about only matching a partial region of the object to each other, or even not requiring any location match at all, but instead just requiring some features to be present.
Yeah. Are you happy for me to write something here, Jeff?
Yeah, sure. Go ahead.
So yeah, a partial match can still provide evidence for an object.
I'm going to stop. I'm not seeing what you're writing because I'm looking at I'm not looking at the Zoom window.
Oh,
I think maybe if you click out of the text box, because I see it on my screen.
No, the problem is
yeah, but I'm typing it, so it should be appearing on your screen. It's appearing on yours.
Excalidraw is not real time. It's close to real time, but there could be lags.
Maybe.
Isn't this a problem? Because am I looking at? I don't know. I should see it, shouldn't I? I don't see it.
Yeah. Anyways, I'm sharing my screen now, so you've seen a few.
Oh, let me stop sharing mine. All right, you can share yours. That's nice to see you all again. It's like sharing my screen. I can't really see you. I don't want to have it blocking the screen.
Yeah, one fun anecdote before we're done with this topic. I'm watching Link learn object categories right now and assign words to them. And he basically calls anything that can open and close a door now. So if he wants us to open a box, it's like door. If he wants us to open a jar, door. If he wants us to open his bottle, door.
Love it.
So
It's the affordance. Door
very
basically means
clear.
open to him.
It's a
Yeah.
useful clue. I'm not sure what to make of it yet, but it's a useful clue.
I have a similar one where our kids thought the dog was called Gentle because we kept saying gentle every time they
Oh,
went near the
Link
dog.
did the same, yeah.
Wait, say that again. Sorry, who?
The,
I was writing.
The twins, whenever they went near the dog, we would say gentle, and then now they think the dog is called Gentle.
Love that.
There's
Oh.
one that I think of sometimes is I saw this video a while ago of a dog that, you know, those tennis ball launchers, they can drop a tennis ball into it and it'll shoot it out.
Yeah.
This dog kept trying to drop its frisbee in there.
Are you serious?
Yeah, I'll post it in the channel, but I
That's
mean,
great. So the
it's
dog
like-
figured out this thing throws things for me to catch.
yeah. So in some sense, frisbee and tennis ball are in the same sort of class or category or something, despite being very different morphologically.
Right. Yeah, that dog needs to use its morphology models a bit better,
Yeah.
Yeah.
or
Hey,
its collision models maybe.
So Niels, I'm now looking at Excalibur and I see affordance. Oh, well, you're still typing. I didn't understand what you wrote. What is that? Oh, well, you'll describe this one.
Yeah, we'll just I'll check if you guys are happy with this. So I guess the things I added. So yeah, this is what you were saying, Vivian. And this kind of relates to the example you brought up, Jeff, that yeah, partial match. So we might see kind of parts of an object. We might see kind of wheel. We might see car door, and then but in no particular arrangement, but we're still accumulating evidence because we're getting features. And so, that could be enough to kind of light up a column and say, okay, it's not like a great match, but that reminds me of a car. And then this is just, again, something I feel was touched on in that old point for 2 you had. So just to make sure we kind of keep that. And
Oh, I'm sorry. I was looking at the thing you wrote at the end here, but you're talking about stuff at the
this
top.
is the
here.
partial match thing I was just talking about.
Oh, I mean, a partial match can still provide evidence for object class. Feel like one of these objects are color. You're right. Okay.
And then, just emphasizing this point that we get generalization because we can kind of have some tolerance in location in our reference frame when matching, as we kind of move and where we expect something to be, you can have different levels of tolerance for that. And this was something we discussed the other week with our composition figures. In general, if you have child objects, you can generalize quite robustly. So this is like where, the relative arrangement of car parts doesn't need to be perfect. You can just recognize lots of different things as cars.
We don't have any representation of relative arrangement of things, do we?
Well, we do in the reference frame. Well, what do you mean?
But the reference frames are locations. They're not.
Yeah, but they implicitly capture the relative
right
arrangement.
implicitly, but I can't read it out easily. Right? It's not like if I just store three things at 3 locations, the relative position is not represented separately. I could deduce it.
No. This is just as learning modules and columns already exist in the framework. Sensory motor exploration means that we will move through a reference frame. We will be sensitive to the relative arrangement, but you can choose how precise or sensitive you're going to be after you move. Or like a learning module or a column could be more or less strict about matching its prediction at a location.
I think there's more to it than that, but I mean,
okay.
It just seems to be.
So always great when summarizing when it starts opening more cans of worms.
Well, but I
guess yeah.
This
I
is
thought
exactly. Go ahead.
Yeah. Anyways, and
I think
this
this is
the last point.
I think this is good. I mean, look, at least we've narrowed down things quite a bit from when when I started here, when we started. And so I now have a visual imagery in my mind of maybe like a picture what these object models might be in a hierarchy. And then we can explore and see how far we can go with this, right? We can see, I don't have to think I'm not going to think about class objects being a separate object. We're just going to say, no, we're not introducing anything new. So how can we get this to work in a hierarchy? And in a hierarchy, we're also including child objects that are behavioral objects. And we can attend to parts of an object and see the similarity in parts of an object. I mean, it just gives me, it's a reduction of the search space, right?
Yeah, the beautiful thing about it is we have to change nothing about the system.
Yes, I know,
Right.
but that's just always a desirable thing, but we can't let it dictate in the end. If we have to change something, we got to change something. So we have a strong bias not to, but see how far we can go with it.
I have a question, but it's on the same topic. Can I just take maybe 5 minutes to ask it, like 2 minutes?
Yeah.
Share my screen.
Okay.
So if we're thinking of stacked LMs, I was thinking of an object. So if the lower level object is representing things more morphologically like this, but in a higher region, we may be thinking of more abstract representations that can combine multiple objects into a class and can group them this way. So for example, these here, they have like this same kind of, for class ID1 in the lower level, they have the same kind of morphology, so they'd be maybe grouped in the same class. Whereas in a higher level, it'd be more grouped by function or by where they appear in, like these are kitchen tools, they appear in like around the same place in the kitchen tool.
Well, I mean, I'm confused. I thought in the lower one, there wasn't a class ID for these things. These are specific objects down there, and the class ID only surfaces the output of the higher level modules. That's what I thought we were saying.
Yeah, I was thinking that things could also, like in the lower level, they could be grouped by morphology more.
But that's inconsistent with just a state. That's inconsistent with what we just said a moment ago. Like the way I would have thought, the lower learning module I'd have a model of the drill and the model of the blender, and they were separate models. There would be no connection between them. And only when you got to the next higher level learning module, there would be an object ID that incorporated both of them.
Yeah.
So there is no class ID versus object ID, and a lower level wouldn't have two objects. It wouldn't have there would be no class ID concept down there. It would be separate. That's how I interpreted it.
Yeah, I guess I was thinking more again, which I know you don't agree with, Jeff, but thinking more about like how like if they have more overlap between their bits, then they'd be
all right. So you're into well, you're gonna bring that back in. Just gotta state it so I know where you're going. Okay,
Yeah,
so you're saying there is a single ID, but that ID is encoding both objects.
Yeah, slight variations in between them would be encoding.
Is that right?
That are like you'd have like there's a class ID there's an ID for things that look like this, and then small variations in bits would encode different objects that are like within this class ID. Jeff,
I don't know if it's also just helpful taking a step. Oh, did Jeff disappear?
I just dropped out for some reason. Everyone else dropped out.
No, yeah.
Zoom stopped and it started again. Okay, back.
Yeah, I don't know if it's helpful. I mean, just to clarify in this example, so if we're going to use the term class ID to refer to the output of a column, personally, I don't feel like it's better not to make a distinction. But if we're going to say class ID is the output of a column that models based on child objects, and object ID is the output of a column that models based on direct sensory inputs. Is that kind of the distinction you were going for, Jeff? Or
Well, I'm just pointing out that we had we can talk about the terminology, and
Right.
we suggested there was a continuum between these, right? That was the
Right.
suggestion.
Mhm.
So
Which
Yeah,
I
we
guess I
just
feel like
call
if
them
there's
all object IDs, and then
exactly,
you
I
know
feel like that's
conceptually.
right. So
I
I think that's what we should do. We should call them all, object IDs, and in the range of object IDs, there can be a variance in between the emphasis of in the model of sophisticated
right,
features versus specific morphology components. But the
right,
model, at the moment, we should assume that the model doesn't really care. The model just is going to get inputs and it's going to figure out what to do.
right.
Um,
And then I
so
guess, but then yeah, so Rami, your first example, it is a more abstract example because it is receiving child objects in this case. It's not, that's what you're showing at the bottom.
Yeah.
So it's somewhere on the continuum towards using kind of coarse representations.
Yeah.
I
Well,
just thought that was worth clarifying that,
right.
yeah.
My
But,
thinking here was that object IDs for these two objects are going to be more similar, and therefore there would be a class grouping them. Like if we subsample from this SDR.
all right. So you're introducing a whole new idea. Which today, it's previously you introduced it. The idea that class could be based on an overlapping of SDRs.
Yeah.
Okay. Well, that's a whole new idea. So, but it's inconsistent with what we just sort of, well, it's an alternate to what we just suggested earlier. The alternate would say, take something like V1. V1 would almost be completely based on morphology. And would have, and so the models that we have there would be very detailed morphological models. And you go higher up in the hierarchy, those models would be almost completely based on sophisticated features, high level features that are already the compositional models themselves. But that's different than what you're proposing here.
Well, what I'm saying here is that the lower levels are also in the lower regions, like in V1, if we're doing this grouping, then the grouping would be based more on morphology in the lower regions than the higher regions. In the higher regions, we're looking more at
So
abstract concepts.
in this example, are you saying the lower column can't distinguish the drill from the mixer, or
It can
distinguishes
based on
them and
variation. Yeah, each one of those still have object ID within this class. It's just that these object IDs have a lot of overlap for them to be grouped in the same class.
But then what do I do with
but
that?
then class ID 1 doesn't exist. It would just be two object IDs that are similar.
Right. Yes, this grouping is just
Or
missing.
class ID is encoded by overlapping bits between the drill and the blender.
But it sounds
But I guess what was maybe just taking a step back, I think you started with there was like a question you had or something. Because yeah,
Well,
I
yeah,
agree with Jeff. This is opening like a big new topic. So I guess given the time we
yeah.
have, maybe just worth clarifying, like we can always revisit this, but the connection to kind of what we were talking about today.
The question would be for is it reasonable to assume that there is another representation of these objects in the layer 4 of the higher region? So the higher level class ID of something like this, like the object ID of the mixer here would be closer to a spoon, like a fork in the higher region than it would be to this drill, for example. But that would be represented in layer 4. It's like two representations of the same object.
I mean, it feels like that feels pretty specific, but I mean, I think a high level interesting thing that this explores is like how you can use context to maybe build that representation of affordances, which is like, you tend to experience an object in a certain setting, or maybe use an object in a certain setting, and that's what slowly informs the kind of class of like affordance. But and maybe that gets to like the sort of heuristics that we were talking about earlier, Jeff, about like you don't search the entire space of like, could I use this as a power drill? Could I use this as a chair? Could I use this as a
The way I
denture or
think
whatever?
the way I think that would work would be more like you attend to subsets of an object, and then you, based on those subsets, you reach a sort of an inference of something. So I think, Rami, I know this idea of the shared SDRs is still in your head. I'm not saying it's wrong, but it is a major departure from everything we've done. And I think the reason we would go there, explore it, is if we run into a roadblock we just can't resolve. We got a path, it's working well. If we run into something we just can't do, there's no way, and it forces us to say this must be occurring, then that's a good time to explore that option. I think as a group, you could explore it all you want. I mean, I do crazy stuff all the time, think about things. But not that I'm saying you're crazy. I'm just saying I explore ideas that are mine. Don't go anywhere. But as a group, I think we don't want to take this, spend too much time on this until we force ourselves into it, until we come to a conclusion that there must be this capability and we haven't observed, we don't have a way of doing it. And then we could go back to it, but it's not like, hey, how about this again? Maybe we have shared SDRs. Well, we might, but it's a fundamental shift in the whole thing. So it's
Yeah,
just
no,
the
I
way.
agree. It's different in the way that we think about SDRs.
Right. So that's the way we have to wait till we hit a roadblock that we can't resolve, because it would upset a lot of things. But if it has to, it has to. But at the moment, I don't want to think about it. The whole goal. My whole goal today was to narrow down the search space, not add another one at the end there.
Yeah.
So just keep it in the back of our mind.
Sounds good.
Yeah, what do you reckon, Remy?
Can maybe
you
talk
the-
about topics for
the focus
week?
week.
Yeah.
Cool.
How far out in the future is this? How many weeks? No.
2 weeks. So it's the first week of February. So we basically have one more research meeting before. So I thought it'd be good to talk about topics. So maybe next week's research meeting we can kind of do a bit of a preparation for the focus week and
Right.
outline the big questions we want to think about and some examples we want to solve.
Nice. Thanks.
Okay.
And yeah, I guess we've got a little bit of time. I had some thoughts on the meeting from last week that I could try and quickly cover.
Yeah.
If people are for it, just to because I feel the longer time goes by, then the more it kind of disappears. And it's always nicer than on Slack. So cool. Sorry if I seem distracted. I could just hear Kai is not very happy downstairs. So
I know that feeling. I hear Link screaming in the next room too.
Okay. I'm sure he'll settle down in a bit. So yeah, I thought it was a really interesting meeting, and yeah, I just thought kind of one highlight that I just thought was worth kind of repeating, because I think it's an important message that maybe has kind of come up before, but it's just a really kind of key point, which you had kind of talked about, Jeff, was just that when learning that we only attend to, and pass up one object at a time, at a location. And in particular, I thought there were some nice specific examples of that, where, for example, if you have kind of multiple fingers touching a handle, kind of multiple finger pads, you can imagine, either they already know what a handle is and they can kind of pass that up. And so we have that single object at a really what's kind of a single location in space. Or if we don't know what that is, then we need to kind of drop a level down. And then each pad, you would have to learn individually with a single pad. They can't all be learning in parallel. That's just too much to kind of, yeah, for the system to deal with. And then the multimodal example of that came up was kind of, again, if you were learning on this mug while you were looking at it and touching it, if these don't correspond to each other, if you're kind of looking here and your finger's over here, you're not attending to the same location in space, and you cannot, the models that are receiving inputs, or a model receiving inputs from both of these, cannot learn kind of simultaneously about these two different things. Unless, again, let's say both the eye and the finger knew what a mug was, then they could be recognizing a mug and they could be passing it up. And then you would be learning, oh, there's a mug here on the coffee table. But if you don't know what a mug is, then you need to, again, just kind of focus either on one modality, if it's kind of the attended space isn't shared by another sensor, or they need to attend to the same location in space. and then kind of multimodal learning can happen. And then yeah, and
Right.
this
Uh,
bottleneck
uh,
does not, right, sorry.
Keep going. I'm just saying, if you're saying, are you summarizing it well? I say this is great.
Yeah, I'm basically
It's
just summarizing because I just feel like
it's a great
it's an
summary.
important point that yeah,
All right,
that's
keep
just
going.
it's kind of slowly become, I think, clearer. It kind of relates to stuff we've talked before, but I think it's just slowly become clear the more we've talked about this global attention and all this kind of stuff. And it just feels like a really key kind of constraint to have in the system. And yeah, but this bottleneck does not exist for inference. So yeah, this is the example of kind of driving a car that we talked about, where you can kind of leverage models in parallel. And yeah, I think what was also interesting, which came up yesterday, was just that yeah, this was a while ago. I kind of brought up how it feels like with learning motor policies that when it's an entirely new one, you really need to attend and do it in a kind of serial fashion. Like for example, if you are learning to kind of grasp objects for the first time, it really feels like you almost need to kind of like focus on one finger and move that, and then focus on the other finger and move that. Um, and that's kind of how we learn like new motor policies. But that over time, of course, we have systems that can then learn to kind of automate that and make that much quicker. But it just, I don't know, it just seemed interesting that there's this parallel between learning objects and then learning action outputs. That again, there's this kind of constraint on attention, unless we've already learned about something, in which case we can leverage more kind of parallel, more automatic resources. Um, and I think it's nice because it makes learning much easier. Like, I think one of the things that really distinguishes what we're doing with so many other kind of AI systems is that most learning that we're doing is just like really simple Hebbian learning. And that works because we're always kind of focusing on a point in space, at a point in time, and there's this kind of locality to representations. If you don't have that, then Hebbian learning just kind of becomes a mess. And yeah, so I just thought that was worth repeating. And then, because yeah, I think that'll be important going forward. I
Right.
thought there was and then yeah, there was a bit of discussion. I think Rami, you were asking a question about a car and kind of how many objects we can attend to at a time. Because I think in the context of the above, the question was like, oh, does that mean we only attend to one object? And I just thought it was worth. I wasn't sure if from that discussion you got kind of a totally clear answer, because I think it can sound like we're talking about one object, but really it's one object in a reference frame. And so in some sense, it's two objects that are concerned at any given point, but one is this kind of parent and one is the child. And so like that's the example that is in the hierarchy paper. So when you attend to the door handle, that door handle exists in the reference frame of the door. Or when you attend to the door, that exists in the reference frame of the car, or the car, maybe that's in the car park. But there's pretty much always this kind of parent object and then the child. And it's where we are in kind of space is well, I guess there's this kind of global, almost like egocentric location, and then there's where we're modeling we are in the reference frame, and then there's what object we're perceiving at that point.
But in terms of
By
comments,
the way, I just lost you for the last 15 seconds. You froze, but keep going.
Oh, okay. But okay, yeah, but I don't think it's anything you would disagree with, Jeff. And
Yeah.
I just
Hey,
thought hopefully that's a bit clear, Rami, or maybe it was already clear.
Can I go ahead? Well, go ahead, Rami. I want to add something on top of this recent observation.
Please do.
One of the things I was asking myself is like, when we learn this hierarchical composition, how does in your tending to something, you have to have two reference frames active at once. You have to have the parent reference frame active, and you have to have the child's reference frame active. Two different modules, two different columns, learning modules. But you have to, because the child has to be recognizing the child object, and the parent has to be establishing the reference frame in which to assign the child to. And so I was asking myself, well, how's that distinction made? When does it decide? When you attend to something, what happened? And I ended up going down if you follow the problem, it's sort of like, okay, let's say I have 5 columns, 5 regions in a row, or 5, hierarchically stacked learning modules. How do I decide where the parent is and where the child begins? And I worked through a whole bunch of it, and I came to sort of a temporary conclusion, which I'll just throw it out because you'll hear it again. That it can actually be physically hardwired in some sense, that the size of the area you attend to might actually dictate which level in the hierarchy is learning the parent and which is learning the child. That it's not determined otherwise. It's just determined physically by the size of the attended area. This seemed to solve a lot of problems I was having. So it's not a problem we've talked about. So I'm proposing an answer to a problem we haven't really talked about. But the problem is, how do you, in a series of these things, how do you decide where you divide the line between the parent and the child, and therefore where learning will occur and all this kind of stuff. There's a bunch that comes out, and the answer might be that it's physically tied to the attended area space. So I just threw that out.
Yeah, it's interesting. And you mean like the sort of, if you imagine attention almost as like a sphere, kind of like the size of that is
Really,
determined.
literally the size of that. Imagine you have the entire world is the largest space, right? And then remember the surface of the hippocampus, the surface of the supracollicus sort of represented the entire space around the animal, and then any points in it. Anyway, so you have this representation of the entire space. Attention is attending to some subset of that space, and the size of that subset would dictate which is the parent columns and which of the child columns, where that dividing line would occur.
Yeah, interesting.
Right. It seems to solve a lot of problems I was running into, and so I just throw it out. It'll come up again. As soon as you start doing this in more than a 2-level hierarchy like we did in the paper, then you have to say, well, where's something occurring? Where's the parents? Where's the child? Who's the child? And who's the parent? How many parents do I have? All these kinds of things. It gets a little difficult.
Yeah,
Right.
I keep wondering where in our research roadmap when we will need to add attention to Monty. And
Soon.
yeah, it sounds like once we have more than 2 levels of hierarchy.
Right. I think pretty soon.
Yeah,
It's already
definitely keeps coming up more and more often in our research meetings.
right.
So.
It's already in my sort of canon of thinking. I'm constantly thinking about it. That's why I mentioned it. It was that was one of our topics for the focus week.
Okay, nice. Yeah, Rami, any?
No, I think Jeff answered it. I was just mostly thinking about, if you have a child object and you have a parent object, what are we attending to? What columns are we activating? Or because in an area you can have 5 levels of abstraction. Like you can have right, and for specifying it by the area, then are we attending to all of those in this area, or is it like just 2 levels in this area and it just keeps switching?
Yeah, so I think we've for a while been confident that it's 2 levels at any given time, and what objects they're representing can change, or what 2 levels in the hierarchy are active can change. But yeah, as Jeff was just saying, I guess we've not talked about like how do you actually decide, other than through like inference, I guess. Even then, yeah.
Even inference is weird, because
even inference is weird, yeah.
Right, because I could be inferring to an area, and you might say, oh, it's a big area, and you say, well, V1 is observing that area, so maybe V1 is doing inference, and V2 is an area, so V2 is but it's just like it is complicated. And the thing I just proposed is a simple solution to everything. Essentially, once you define an area, it would work across modalities, vision and touch or anything, where you'd say, oh, in this hierarchy, the attended area would dictate these two regions are the or these 2 levels are the parent and child ones, and then that matches, because the hippocampus has the same set, right? The hippocampus has like 15 of these levels, or 10, depending on who you speak to. they could match do the exact same thing. Which columns in the hippocampus or which good cell module equivalents are learning this temporary model would be dictated by the same area of attention. So you can have anyway. I think it's a time for a future topic to talk about, but I think it might hang together well.
And so the area of attention at any one point in time would define the child object, like
It would
in which region you recognize the child
It would,
object.
it would, right. It would define the region which recognizes a child object.
And I guess that would that kind of fit with, like you've often talked about, kind of if we don't recognize something, we kind of narrow the attention window.
Right.
So that would
right.
literally scan through columns in the hierarchy.
Well, it would just basically say, go
So
down to the next smaller size and the next region down to find out what
right.
this,
But that's
this
what I mean.
object
But
is.
that's kind of nice because that kind of gives us yeah, that's like a natural way to search the space of all the columns we have.
Right, right. It's so like as you narrow your attention window, you're actually shifting which columns are going to be the ones responding to that attention window. It's a physical thing. So like if I'm recognizing a small letter on a screen, well, some high level visual regions getting that input too, presumably, or getting something, but it's not going to be very useful. And so how does the system decide who should really be learning right now?
Yeah.
And the physical size
I
of the
wonder-
attention window can dictate that.
I wonder if there's any neuroscience evidence for this. It feels like the kind of thing that might already have some research on, where they, even just with something as coarse as fMRI, they could kind of see how attention, but as you change your kind of window of attention, how that influences where
Right.
the cortex is lighting up.
It's a good question. It's worth looking at. The last time I sort of read about attention stuff was many years ago, and I found that the conversations in the literature back then were kind of really not very useful. They because they're doing it without sort of the context that we have of like models and how models are learned, and so people can talk about attention without any kind of idea of how cortex works, right? Or they might be psychologists, right? And there's a whole bunch of psychological literature about attention. And so it's just really difficult to correlate between them. But I think, you're right. Now we have a whole bunch of new stuff they could talk about that. They might have more information on it.
Nice. And then, yeah, I guess maybe the last one to briefly, just before the coffee corner for those going. Yeah, this kind of gets into the distributed learning, and it just feels like there's some maybe interesting connections to the imagined representations, where, so we talked about kind of how if you have different columns, higher level columns and then lower level columns, and then this lower level column is actually getting direct sensory input, it's inferring something and sending it up, and so this column is learning some compositional object. But then with distributed kind of shared learning, we want this column to also be able to receive an input, essentially a feature, which would be a child ID down here. So that's the kind of sensory or kind of child input. It's also going to get movement information. That'll be the global attention. And then the question is kind of how you activate this. And I guess voting, of course, is kind of the natural suggestion. But it's always seemed to me like with voting, we don't want to hallucinate things. Like if you hear the sound of a cow mooing, you don't actually start kind of seeing a cow in front of you. But your kind of visual representation, your imagined representation of a cow might become active. And I feel last time we talked about imagined representations in the case of learning reverse causality, it seemed important that the representation spikes in order to actually communicate with other columns, but is still somehow distinct so that you understand that it's imagined. And it feels like we need the same thing to happen here, that like L3 kind of needs, there are cells that need to actually spike in order to transfer information up to R2 column B.
So
But we don't want to hallucinate that, oh, I'm sensing, I'm touching this, and suddenly I think I'm seeing it as well.
I think there's two things you're talking about here, and maybe they may separate it apart. One is like, I hear the sound of the cow. um, I don't immediately imagine what the cow looks like. I don't immediately imagine what the cow feels like, but I can if I provide some additional information. So if I said, if I even said to just, imagine I hear the sound of the cow and I'm in a field and the cow's behind me. So I know if I turn my head, I'll probably see the cow. Or, or if I'm given partial input, like show me just the picture of the tail, I can imagine the rest of it. So it's sort of like, and the way I view that is happening is like you got your voting layer, which is cow, and the cow can be invoked. The voting layer for cow can be invoked by sound, by touch, for hearing. It's a class of cow, and all these columns are getting it, but without any additional information, they don't actually activate. They're just, you don't imagine it until if I give some partial information to these columns, some additional information, then the class of cow plus some additional information might say, oh, well, given this, I see the tail, I can now imagine what the rest of it is. This is all hand waving, excuse me for this, but so that seems one kind of imagination where it's just like you have anticipation. You recognize a cow, but the exact modality for imagining it isn't really selected yet, or you hear it, but you haven't touched it or seen it. And that's just the voting layer. There's the other imagination we talked about earlier, where you're actually walking through a sequence of stuff, like imagining what do I have to do to make the coffee pot, where I'm actually going through a sequence of states and following the consequences. That's to me a very different type of imagination. But maybe you weren't talking about that. But here again, there's a case where we want to use the words. We have to be more precise in our language, because I think one multimodal anticipation of a recognized object is different than walking through imaginary steps in your head.
Yeah. Okay. I mean, yeah, it's probably too big a topic to chew now, but I guess I feel like they might be the same thing.
They might be,
but-
right. And just even talking to you, I think it could be the same thing, but you really got to tease apart why both work in the same thing. It's
Yeah.
like,
But
right.
yeah, anyways, I just thought that connection might help us think a bit about what the like neural basis might be, or something like that. But